Good afternoon. My name is Justin Johnson. Today I'll be presenting the scenario for Patient Travel Support, which is a global nonprofit that offers travel subsidies for those needing medical treatment. They operate out of APAC, EMEA, and AMERA regions with 10 different offices per region. Their objectives are to deliver a unified, scalable platform for the patients to apply for coverage or apply for subsidies that will supplement their coverage, and then that would then replace the regional databases that are currently disparately managed in different regions. The risk identified is the large data volumes, projecting 38 million patients in 5 years. This will be, since this is operational data, this will need to be maintained on platform. These records will need to continue to be maintained and persisted on platform, and we will optimize the read operations for these records with skinny tables and indexes for the patient records themselves. Another risk here is the health insurance latency. The platform has sometimes during peaks, 15-second delays for reading data and returning responses. So what we'll do is decouple the integration using an API layer, which is the ESB in this case, and then also optimize for read operations prior to the requests being made as well. Finally, there is the risk around PHI and PII, so we'll enable Shield, and that will enable also the private key storage within Salesforce. Some of the assumptions I made is that Salesforce will be the system record for patients, the applications, the assessments, the treatments, and the medical history. The insurance record will just be the system record for coverage itself, and Salesforce will rely on the health insurance record for that information. And then the identity layer that I've identified is going to be Okta as the identity provider. And then Facebook will act as the external identity store, and Active Directory will be the internal identity store. We'll start with the actors here, which with the internal users, internal actors, the managers will receive Service Cloud as well as digital engagement for the live chat as well as case management. Assessors will receive the same for the same reasons. Their role hierarchy will go from the managers to the assessors, with record visibility rolling up from the assessors to the managers based on ownership. The patients will receive customer community license for access to their own records, and the MPs, which I will call medical practitioners MPs from now on, will receive partner community license, and that will be for the account teams they will be a part of. The solution uses a single org to unify data processes and collaboration. This will be leveraging multi-language via custom labels, Salesforce email templates, and translation workbench for the translation of metadata via a translator. Multi-currency will be enabled for the multiple currencies that are a part of this global rollout here. And the single org here will have digital engagement installed for the live chat feature for the communication between the internal users and the external MPs and patients. Locate will be installed for the address validation as well as the return of the geolocation. Einstein Bot will be enabled for the deflection of chats based on whether or not an agent is needed. And then Shield be enabled for the privacy center as well as for the key encryption of data at rest and in transit. The internal users will authenticate using SAML via Okta. Okta is backed by separate Active Directory stores per region. Okta will route to the Active Directory stores based on the region of the internal user. The external users will authenticate using OIDC via an auth provider that returns an IT token that's validated by the auth provider and then sets up that user within Salesforce. The solution takes an API-led approach to integrations using reusable APIs. managed by an ESB and secured by a job-based trust model. The ESB serves the purpose of buffering the request and response from the health insurance checker, given the fact that during peak times it can also be 15 seconds until it returns results. We will use the ESB to absorb spikes during the peak times. Okay, and then of course the ETL here will facilitate the migration of the data from the different regional databases to Salesforce, and I'll talk about that during the migration as well. We begin the process and the requirements with the patient being onboarded. The patient will onboard themselves using the patient portal. The patient portal itself will have a registration option that is supported by a self-registration handler for the username and password-based registration, or they can choose to log in with a social sign-on provider, which in this case is Facebook. Facebook returning then an ID token to the auth provider that's set up in Salesforce, which validates the ID token and then creates a user and a person account for them within the core cloud here. The user, once they've been set up as a user, the patient, once they're set up as a user, will be able to access and be redirected to a screen flow that will allow for them to input their name, email, date of birth, address, language preference, and insurance. I'm assuming that they will already have inputted their email when they initially registered, given the fact that they will need to do a password reset, and also Facebook as well enforces email for the registration. So what we'll do is when they are initially brought to this login screen flow, show a screen that confirms the accuracy of what they're inputting so that they will confirm that what they're saying is correct. This serves two purposes, not only just the confirmation of what they're saying is accurate to what their current state is, but also it serves as a buffer so that we can return pre-populated data from the health insurance checker, while also keeping in mind the constraint around the latency that the health insurance checker is prone to, which is 15 seconds. So we're assuming that they will spend at least 15 seconds, if not more, on the confirmation of the accuracy, and then that will give enough time to pre-populate data from the request reply that integrates with the health insurance checker and pre-populates a second screen with the name, date of birth, address, language preference, and insurance information. There will also be, when the address is returned by the health insurance checker or it's inputted, there will also be the locate package that enables the platform to validate addresses that are edited or inputted, and also returns a geolocation that's stored on the patient record. Once they've completed this master data about themselves, they will then be able to apply for a subsidy. The enablement of the application for a subsidy is via a flag on their person account record. Once that flag is set to true, there will be a record trigger flow to initiate an email to the patient based on a Visualforce email template that it has multiple languages supported via custom labels. This email itself will have a link that will redirect them, once they're ready, to the order layout or to the subsidy application layout screen here that will enable them to actually then apply for the subsidy. So when they click on the link, they're brought to the creation screen, which is a screen flow. The screen flow itself first creates the application. They will then create order item records for the different treatments that they're applying to be subsidized for. So the products here in my object model represent different treatment types that are offered, and then the treatment types that they're interested in applying for are listed here as order items under the order, which is the subsidy application itself. When they do apply for a subsidy application, They will also need to confirm the medical history information. So this will be facilitated by a separate custom object for medical information, which is private OWD. That that medical information will have a lookup to the patient's account, and the application will look up to the medical information. Once they've confirmed the medical information, the application will be populated with that confirmed medical information record. The medical information will be persisted and will represent the record for future applications as well. In case they want to apply for another subsidy, they can use the same medical information record, or they can iterate a different version of the medical information, just cloning it, so that it can then be applied, or to be edited so that it can be applied to subsequent applications. The account insurance that was initially inputted during the onboarding is stored on the person account record. That insurance number is used to check to see if the patient's health insurance covers travel costs. What we'll do is, whenever the account insurance number is updated, we will already be doing via rec-triggered flow, a call out to the health insurance checker integration to return a flag for whether or not they are covered for travel costs. If it returns that they are not covered for travel costs, then they will be able to apply. Otherwise, they won't be able to apply. The reason why we're leveraging the rec-triggered flow here is in case the patient updates their insurance, then we need to continuously validate that based on the health insurance checker information. This is also to optimize for the read operations, given the latency constraint that is existing on the health insurance checker integration or platform during peak times. The subsidy application is stored as an order. That is then, once it's submitted by the patient via that screen flow that I mentioned, that will then update the order to be activated, which will then trigger a record triggered flow to create a case that represents the actual assessment. The assessment is allocated to the appropriate medical practitioner based on the mapping of MPs to different treatments. This will be facilitated by the MP treatment object that is a junction between the treatments and the MP accounts. The MP will first be routed via a approval record triggered flow whenever the case is created. That routing will be facilitated by the creation of the process instance record, as well as the process instance work item record that is embedded within the approval trigger flow. The MP assigned to the case as well will also be determined by the geolocation, so not just the mapping of the products to MPs, but also to the MP's location. So the geolocation of the MPs are stored on the MP account records, and those MP account records, what will happen is that whenever a case is created, there will be a calculation of the closest MP based on the mapping of the product to the MP, as well as geolocation, and then that will then be the MP that is assigned subsequently. So once the case is submitted to the MP, that will mark the case as pending approval. That will then notify the MP that they need to approve it or accept it accept the application within 3 business days. The first step is, of course, the MP accepting it. If they do accept it, then that will create medical history share records for accessing the medical history of the patient, and then also update the case status as approved. If in case the MP decides to decline to assess, that will then trigger the same record trigger approval flow that will mark the case as pending approval and then assign a new MP based on the process instance work items that have already been created for that case. So we're not assigning it to the same MP twice. The MPs will be able to chat, and patients as well will be able to chat with the assessors that are internal throughout the process. This will be enabled by the live chat. Another ask was the ability to deflect support requests that are common. This will be enabled via Einstein bots that will redirect chat requests that will be the first line for chat requests before they're routed to an actual user, internal user. The current process described here describes a process that is flat file based and PDF based and email, and routing is done via emails. What we'll do instead is have the case record represent the assessment that the MP will be able to fill out with the fields that are needed. If there is additional documentation that is needing to be attached, they can attach that to the case as well. And then as a part of the data migration requirement for the 5 years of data, we will have MuleSoft, intelligent document reader, be able to read the documents themselves and then create the different assessments as records within the big object here. Since they are historic records, we'll be just migrating them into the big objects, but they won't be stored as flat files. They will be digitized. Okay. The cases, once they are assigned to the MP, should be escalated to the team managers based on an escalation rule. If it goes through the escalation rule, if it's been assigned for 15 days and is at the status of pending, that will then mark the case actually as the status of escalated, and then assign the owner as the team manager so they can then respond. The medical MP will be able to assign additional specialists via the case specialist object here. That case specialist object will have a record trigger flow that will add account team members for the patient, a part of the patient's account, with and that will grant them read-only access to all of the cases for that patient. So not only will they have access to the current case, but also to all other active cases that are needing to be viewed. The MP will, once they are done with the assessment, they will then update the case to the status of approved. That will be done via a quick action that will update the case MP field to null, so they lose access to the case itself, and also delete the medical information share records via the deletion of the account team member records. The assessor will at that point be responsible for the rest of the life cycle of the assessment, so they'll access then the case via their visibility from the queue that they are assigned to. They will be able to, within the case layout, be able to see an LWC map rendering of the geolocations of the MP and the patient, and be able to, from there, also determine the distance between the two, and from there also determine the subsidy amount that is going to be supported for that patient. So on to the data requirements here, we have large data volumes, but we're taking a tiered model here. We're separating the data based on its classification of operational or non-operational and master data versus transactional data. So I'll call that out as we go along here. The account large data volumes, which amount to 338 million in 5 years, is operational and will remain on the platform, be persistent on the platform ongoing to ensure that patients aren't losing access as they're doing applications. So we'll keep that on the platform, but also mitigate the latency risk here for read operations on the accounts through skinny tables and custom indexes on the person accounts for the patients. Then also we'll apply a retention policy that will archive any inactive patients that, based on some logic, right, where if they're inactive for 5 years, moving them into a long-term storage rather than keeping them on the platform with such large data volumes. And then there would be a process for reactivating them. The process objects I call out are the applications and the assessments. There will be 13 million in 5 years. My calculation. So what we'll do to maintain transactional performance on the platform is we'll retain the 13 million on the platform, but they won't be stored as operational objects within the standard objects here. They will be stored in big objects after they're completed or after they're no longer operational, so that we can comply with the requirement of moving the data onto the platform without while also protecting the performance of the platform itself. So we'll assume that the archival in these cold storage big objects here is in compliance with the intention of keeping the data on platform. And then the existing patients will follow the same process where there are already patients within the existing systems. But for any completed applications or assessments, we'll just move them into big objects already via an ETL, where the ETL will be able to, first of all, extract the data, we'll be able to cleanse, deduplicate, and be able to assign the external IDs and the ordering of the objects from parent to child. And then that's done in supervision of a data steward as well. That data is moved in, and those data are moved into the big objects. That will then enable us to comply with the retention policies. Then for the existing subsidy applications that are currently in flight, there'll be a parallel run that will run for 1 month that will move the remaining operational records that have not been completed into the, they'll keep them off, they will remain off platform, and there will be a parallel run that will keep them off platform. Once they are completed, though, there will be a nightly batch that will be facilitated by the ETL to move any completed applications into these big objects as well. Furthermore, the patients that are already set up within the existing system will also be migrated at that point to the Salesforce org once their application is completed as well. Finally, with the accessibility and visibility requirements, we have the requirement where medical practitioners should be able to see all assessments for patients related to subsidy applications that they're assigned to. So the subsidy applications are assigned to MPs via the case object, that custom field that exists there for the MP. They will, when they are assigned as the MP or they are assigned as a case specialist under the case, that will create simultaneously an account team member record that will grant them access to all of the current open assessments that are that via the read-only access that is granted by the account team member creation. Their access is restricted, though, to the name, the phone, and the email, as well as the description of services needed. This will be enforced by field level security. However, MPs will be able to view all of the can see medical history for patients during the period where there's an open assessment or where they're assigned to the open assessment. What we're going to do is, of course, ensure that we are creating the custom share records that are associated with their users and the medical information itself. And we will also ensure that those are deleted when they don't need access anymore via a scheduled flow that will delete the share records whenever a case is marked as closed by the MP or when it's completed by the MP, so they lose access as soon as it's been moved over to the assessment stage. That's when they would lose access, and the internal users won't have access to the medical information based on the object level security that they'll be granted based on their permission set. And that's it for my presentation. Thank you very much.